I think everyone says that in data science, like the number one rule is look at your data, and this has never been more true.
Let's say I have a project, I've collected a big data set, I want to filter in what are the key filtering techniques that I could use. With Copilot now, with tools like Cursor or other code generation models, do you think that at some point AI will replace us and we won't have to code anymore?
Me and a colleague started building this data set called Cosmopedia, which is a collection of textbooks. And it was generated by Mixtral. And for a long time, we've been training models just on the web, whatever is out there. And if you take a look at what's on the web, some things are really low quality and a lot of advertisement. So when you try to just generate textbooks and things that are clean, it's like you're trying to teach a child. You give them pages that are information dense, that are well written. And this is why this can work like better than generic data.
So you were able to beat the Microsoft model.
Yeah.
Hello, everyone, and welcome to the AI Stories podcast. I'm Leiser. I'm a senior data scientist, and I will be your host. So today, our guest is Loubna Ben Allal. Loubna is an ML engineer at Hugging Face, and she also got a master in mathematics, vision, and learning from École Normale Supérieure in Paris. Loubna is specialized in building code generation models, and we'll dive into a few models that she built, including StarCoder and StarCoder2. But we're also going to talk about a quite important topic for the future of data and AI, synthetic data generation. So if you enjoy this episode, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, so let's get started. Hi, Loubna. Very excited for this conversation. First thing I wanted to ask is, how did you get into the world of data and AI? How did you get into the field?
I was in engineering school. I was studying mathematics, and I also really loved computer science. So I decided to major in data science, which seemed like a good mix of both math and computer science. And after that, I did the MBA Masters, which I think a lot of people in Paris working on AI also did. It had a lot of focus on like deep learning and also research. So that lasted a year. And at the end, I had to do an end of studies internship, which is a very common thing here in France. And I remember I was very torn between like computer vision and NLP because I like them like equally. And that was, I think, way before ChatGPT, maybe almost 3 years ago. And yeah, I just was torn between internship offers. And I remember that I saw one from Hugging Face, and it was about code generation models. It was right after GitHub Copilot, and when I read the description, I was like, that's exactly the internship I want to do. Because just a few months before that, I was doing another internship, and it was when GitHub Copilot was released by OpenAI and Microsoft, and the whole office was buzzing about it. We thought like this was a really cool model that generates Python code that actually works and that you can use like in your day-to-day programming. But there was like no open alternative to that. And the internship that Hugging Face was proposing was actually to build like a kind of a reproduction of that model and to try to release tools for the community to build code generation models. So yeah, when I saw that offer, I was like, okay, I think I want to do NLP and I want to do code models. So yeah, I got that internship, and then I started working on code models at Hugging Face, and I've been there for 2 years and a half and still working on data and LLMs.
Cool, exciting. So yeah, what was this first project internship about? Was it like coding an open version of GitHub Copilot? And how efficient was GitHub Copilot when you started?
Yeah, so it was really the early days of GitHub Copilot, and there weren't even like, code bases or like a lot of tutorials on how to train LLMs. So when I joined, my colleague Leandro, who at the time was my internship mentor, had started a project called Code Parrots, where they basically released like a pipeline on how to scrape GitHub data and have a data set that you can train code models on, and then how to process it and train these models and evaluate it. And the goal of the internship was to continue on what he started, to develop like more tools for the community, to also explore like alternative filterings for the data sets to be able to train some better models. So it was more kind of like an educational tool. It was a small model. Now when I look at the performance of that model, it was really not as good as today's models. But it was like very educational because it was a small model, everyone could use it, and also the code was easy to use. And that internship was one of the building blocks for a bigger project that we started later after my internship ended, which was Big Code, and where we trained the StarCoder models.
And so, in which year did you start your internship? When was that? So that I can put some time.
So that was like in April 2022.
Okay, so ChatGPT was already released.
So when I started the internship, ChatGPT wasn't released.
Okay.
So I think it was kind of at the right time at the right moment. It was the LLM hype. So
And so curious to, so you mentioned you did this small project and then you went to a bigger code model. What's the difference between the model that you used during your internship and models that are currently used today?
yeah. So during my internship, it was a small model. We had, I think, two variants, one that had a few 100 million parameters, the other one that had a billion. It was also trained on very little data because at the time we didn't have like a very large training cluster at Hugging Face. So we only trained a small model for a short period of time. But like, for example, in StarCoder, it was like 15 billion parameters. So it's 15 times the size. And also the data, I think it was trained on like 100 times more tokens. So it's a much bigger scale.
Okay, cool. Okay, yeah, so let's keen to dive a bit into the StarCoder projects. How did you start it? What was the idea? And then, yeah, what was the workflow, the pipeline that you used? How did you collect the data? Which model did you use? How did you evaluate your model? Keen to have a deep dive into that project.
It was so Hugging Face. We were collaborating with ServiceNow. I think we were a team of five, but there was something very special about it is that there was a core team of like full-time members, but it was an open collaboration. We basically had a Slack channel, and everyone from the community could join if they want to help. So it was a bit like a project that Hugging Face did before, which was called Big Science. So we tried to train this model, but like in an open approach, like the community could be involved since the beginning. And I think the projects had like three steps. The first one was collecting the data sets because that's the most important part of like any LLM training. So first we needed like a data set that has a lot of code. We basically scraped all of the public repositories on GitHub. And then we filtered them for data that has a permissive license. And then that's when we released the Stack dataset, which is like the largest collection of like open code. And until today, it's, I think, still a default dataset for training models on code. So that was our first milestone. I think we released it in October 2022. And then after that, we did some experiments to figure out how to filter this dataset. So then we released we trained some very small models because usually you have a very large pre-training corpus. And if you want to know if like a filtering method is better than the other, you can just like say, okay, I have this human intuition. You have to train some models with this new filtered data and see if its performance better. So that's when we trained a couple of small 1 billion models, and we finally like landed on one filtering recipe. So we released a small model called Santa Coder. And then a few months after that, we started training StarCoder. We basically just scaled the recipe like to the whole stack dataset. And we trained a 15 billion model on a trillion tokens. And then we tried to add some other data sources like GitHub issues or Stack Exchange conversations so that the model could also learn some reasoning from that type of data. And then we released like the first StarCoder model, I think, in April.
And so the three steps are data collection, data filtering, and then model training. Are those the three steps?
Yeah, exactly. And I think that we spent a lot of time just on data curation and data cleaning. I think everyone says that in data science, like the number one rule is look at your data. And this has never been more true. Because I think what makes one model better than the other, for example, what makes Llama 3 better than Llama 2 and Llama 1 is all in the data. And because first you need to curate your data better, and also you need to train longer. And for example, if you look at these tech reports from LLM trainings, there's usually details about the training and the architecture. But when you go to the data section, it's usually one paragraph that lacks a lot of details. For two main reasons. The first one is like the competitive advantage, because if they share the recipe for like creating the data, people can reproduce the model. And also there are legal liability issues. But I think the competitive advantage is way more in the decision of either like the curation detail of these models.
And so on the data, based on your experience First of all, was it to generate a particular coding language like Python, or it was like several languages and you had a bunch of data on Python, JavaScript, C++, whatever?
So small model usually has like a small capacity. So we were using only three programming languages. I think it was Python, Java, and JavaScript.
Okay.
But the end goal was to have a model that's trained on at least 80 programming languages because we're trying to produce codecs. And I think they also trained on multiple languages. So we did do like data inspection for a lot of languages. That's when actually the community that we had in VCode helped. A lot of people just volunteered to look at the data and try to flag any outliers or suggest filtering methods. But usually we didn't have a lot of crafted rules. We had a couple of filters that worked well across all the languages. We just used different thresholds. For example, you can have a filtering that says if the average line length is more than a threshold, then you should remove a file. It's probably auto-generated. So it's the same filter for all the languages, but we just changed the thresholds for each language.
And on the data, do you use only code from GitHub, or do you also have text? I think I remember I read somewhere that if you add text as well, like the model still learns stuff with text and might be able to even generate better code. But I don't know if you included text as well, or it was fully code.
Yeah. So we added some text, especially in StarCoder2, but the main part was mainly code because this is intended to be used, for example, in VS Code to complete your code, not really as a generic model. So for example, we add the text data that is still related to code, for example, documentation, Markdown, GitHub issues, or pull requests. I think we also added like a small subset from a generic web pre-training data. But yeah, it does help a little bit on like the common benchmarks. For example, if you were to use the model as a chat assistant and then you do SFT, it helps if it's all like some generic information and you can answer like questions. That's all.
Okay, yeah, makes sense. Yeah, documentation is probably helps the model, understand a bit about how to maybe write better code or at least comment it. Yeah, how to comment it and how to make it better. So yeah, I think that makes sense. And how do you then? So you curate a big data set. I don't know how many million tokens, and then you need to filter it. Let's say I have a project. I've collected a big data set. I want to filter it. What are the main things that I should look into, and what are the key filtering techniques that I could use?
Yeah. So I think, for example, for English LLMs, the community has a set of rules for filtering that go back to the Gopher models and Chinchilla, and they apply them and they try to refine and come up with new ones. For code is maybe a bit more recent, but for example, in GitHub Copilot's Codex paper, they had a set of filtering rules to remove auto-generated files. So we used those in the first iteration. And then when we were doing our like ablations, like when I told you with the small 1B models, we tried to like try new filterings. So we tried to use our human intuition. For example, one filter we tried was to look for files that have many comments. So if a file doesn't have any comments, it's probably low quality. So we would remove like all the files that had like a low percentage of comments. And then we trained models on this new data set. It surprisingly didn't help as much as we thought. We tried some other filters, like one that we thought would work very well, which was like GitHub stars, because you would think that repositories that are starred are probably higher quality and cleaner. So we tried this filter. First, it removed a lot of data. I think we kept only files with more than 5 stars, but we ended up with a small subset. And when we trained on it, I think I was the one who launched the run. I was like looking really forward to the results. And then it was like the worst experiment. Like it has the lowest results out of all. Like, yeah, it was very surprising. I think it's because like you like a lot of diversity because there are many repositories that are like open source, clean code, and like could be informational but don't have stars. And it just removes too much data for this filter to be useful. So that's one case where like maybe your human intuition. And for the anecdote, like the paper for these ablations is called "Don't Reach for the Stars." Which mean like filtering for stars is maybe not a good idea. So at the end, like we tried so many filtering things, but at the end we found that like just sticking to maybe some basic filterings and try to tune the threshold for each programming language works best. Now there are some filtering techniques. We can talk about that later, which is leveraging synthetic data to build classifiers that could filter the web. So we recently tried that and it works very well.
And so why do you think that, well, you mentioned a lot is due to the data, why Llama 3.2 is better than Llama 3.1 or Llama 3 is better than whatever. what can they do to make it better? Is it the sources of data that they use? Is it related, you think, to maybe synthetic data generation? What do you think is their key advantage? Maybe because they've got access to Facebook data that others don't. Yeah, how do you think they can? What's their competitive advantage? How can they improve the model so much with just data?
Adding like internal data to Facebook but yeah, it's data curation. So for example, for code, I said that we use a set of standard filterings. But for example, for English text, which I'm working more on now, you can actually find more curation approaches. For example, I think in Llama 3 compared to Llama 2, they started using LLMs for filtering. That's like a technique that really helps, and we've tried that recently, and we found that really helps. You get like better corpuses, and it also works for code. So that's like a new approach that's better. Also, like the text extraction, how you extract this data, especially like for English, when you take it from Common Crawl, it helps to have like better methods. And also just like the data mix, because usually you have data that comes from different sources. You have data from the web, you have data that maybe you bought from books, and then you have like data from code and math. And the way how to mix it is also like a question in research. You need to find like the right way to give to each data source to get like the optimal performance. So I think in Llama 3 they did a lot of ablations to find like the perfect mix. And for example, one thing people usually do is that like they start with a mixture, but like mid training or at the end they change the mixture because the model probably learned some basics, and now we should upsample the high quality data to make the model better. So there are still a lot of things to do with data and a lot of techniques. So saying that, of course, there were like some architecture changes and a lot of work on post training to go like from one version to the other. But I think if you just compare the base models, for example, two of them have the same transformer architecture. What makes the big difference is the data. The other thing is like the length of training. For example, if you look at the history of scaling laws, like when Chinchilla came out, if you were to train a 7B model, you only need like a few billion tokens. But now these models are trained on like 10 trillion tokens. So just training longer in itself already gives you a performance boost. So there are so many angles to look at the data to improve the performance.
I think that's interesting. The point about giving like simple data at the beginning when the model doesn't know anything, and then make using high quality and maybe even more complex sources once the model knows about the world. And it looks like it's similar to what a human is doing. Like at school, we learn simple stuff, and then at university, we learn things that are much more complex. So very interesting to see that this could work with AI as well. And I didn't know about this technique actually.
Yeah, exactly. I think before this, a lot of people tried to do it. It's also called curriculum learning, but it didn't work as well. But I think now, for example, if you look at the Phi 3 models from Microsoft, in the paper, they also say that they did something like this, it's like stage training. And they give an example that's very interesting. They said that the model doesn't need to know the outcome. I think it was a possible match or something like very early in the training. But like towards the end, maybe that could be interesting for diversity.
Okay, so yeah, many things that could be taken into consideration. When do you pass which data into the model? The mix of data, like how much resources should be related to mathematics, history, should be from the web, should be from books, and then
Yeah,
also obviously the variety, quantity of data, and the filter used. So yeah, quite a lot of things
exactly.
that could be used to improve the model. Yeah, so we discussed data filtering. The third part is model training. So in your case for StarCoder, how do you train the model? You also have those steps of pre-training and then model fine-tuning, or is it just a single step training the model end to end?
I think there was much less hype about like chat models. It was more like just base models, especially because there weren't any good like LLMs that you could use synthetic data for. So if you wanted to build chatbots, you have to have like human annotators. So for StarCoder 1, we released just like the base version. We essentially used the standard transformer architecture. We used, for example, multi-query attention. I think not a lot of models were using it at the time, but now everyone is using it with GQA. We also try to have like a long context for the models.
Can you
Um,
explain what multi-query attention is high level?
So basically, in your transformer heads, you can have like in each head, you have different key and query and values. And in QA, it says that you can share the same set of queries and values for each head, and you still get the same performance as if you were to have separate values for each head. So the advantage is that like you don't lose a lot of performance in training, and in inference, it's so much faster because the values that you load from the cache are much smaller because now you have one set for all the heads. And for grouped query attention, instead of having just one set, you have like maybe four or eight. You
Okay.
can choose the value. And they show that GQA works better than MQA. And a lot of people are using it now because it helps with inference.
Okay. Okay. Clear. Makes sense. Thanks. And so sorry, I cut you, but then okay. Yeah, what else did you use in the model then?
Yeah, I think that was maybe the change. The rest was the standard decoder model. And I think it had 8K context length, if I remember. And yeah, we just trained on our corpus for 1 trillion tokens. And then after that, we also released like a 7B model and a 3B model. And for StarCoder2, we used the same architecture. We used a longer context. So we did some context lengthening. Now we have like 16K. And a few months after, we also released an instruct version. So we use StarCoder itself to generate instructions. It's called like self-instruct. And we now have like StarCoder2 instructs.
So for StarCoder 1, you only train on predicting the next token, right? Like text. And so on StarCoder 2, what is this instruct doing? Is it to fine tune the model or?
Yeah, after we had the base model, we like did the SFT and instruct datasets like pairs of instruction answers. It can be used like a chatbot.
Okay, clear. So maybe more philosophical questions on code generation, but with Copilot now, with tools like Cursor or other code generation models, do you think that at some point AI will replace us and we won't have to code anymore? What's your view on the field?
Yeah, I think AI will be more like tools that will help us like work faster and really increase the productivity of the developers. But these tools could definitely be part of every developer's like day-to-day life. And at some point, those who are not using it might be like lagging behind those who are. So it's really important for most companies to integrate these kind of tools into their code bases. And especially now because you have like on device, you don't even need to send queries to ChatGPT. There are very strong models that you can deploy locally and use. So I think these will be like more tools to help developers than actual tools that will replace them.
Yeah, for now I'm aligned with you, and I really like to use those tools. Are very powerful when you know what you want to code. If you don't know what you want to code, I mean, they won't decide for you, right? ChatGPT or Cursor or whatever. They won't decide for you what you should code. If you just give them the problem, usually they can write a lot of code, but it's not going to be great. But if you know precisely, I want to make a graph like this with X and Y axis, and I want to optimize it this way, then yeah, I really like code generation models, and I use them a lot, pretty much every day. Um, but yeah, sometimes it still give you code that's not really optimized, and so that's why I also think it's actually dangerous for people who are beginners, because they will use those tools and they will take the code that the model gives them, and sometimes it's very complex code or codes with lots of for loops that's not optimized, and they will think that's great code. And reviewers, sometimes they can use a very difficult library, something complex, and so if you review the code of those juniors, you think, wow, they're actually very good, but then when you dive in, you realize they don't understand anything.
Yeah.
So if you're junior and you use those models, it can be a bit dangerous, I would say.
Yeah, I think you should be really aware of like the risks and the advantages of using them, especially when you're a beginner. I think this will really change how teaching is done and also learning, and we're still trying to figure that out. They could also be like very useful for learning. You don't need to go like search like Stack Overflow and all the different resources. You can ask one single source, and it could like make you more productive in learning a new programming language. Sometimes you can spend like time trying to debug what it wrote than actually writing it from scratch. So you should already identify use cases where it's useful to have these models and use cases where it's not. But I think the vision for these models is that at some point they should become like strong enough like they can actually handle code bases, and they can handle like a single query over a code base, and it can know where it should go and which files it should change. I don't think we're there yet, but that's like the end goal for this type of models.
Yeah, and yeah, I would recommend for more junior people first learn how to code well, like without coding models, and then start to use them. Because if you do it the other way around, you will never learn how to code well. But yeah, I agree with you that there are lots of other powerful things that you can do with those models, like chatting with the repo, for example, or even chatting with a documentation of a particular library if you want to know how to use it or things like that. So it can definitely be used. For people who are more senior, it can be very, very powerful, really boost productivity. But yeah, for junior people, maybe they should think twice before using them, I would say.
Otherwise, they start programming in English, just
Yeah,
write prompts and
exactly. Yeah, then you don't need to learn how to code actually. So yeah, I want to dive into the second topic. Then we talked a lot about code generation. After that, you mentioned that you also work quite a lot on synthetic data generation. So yeah, how did you start working on that, and what work have you done in synthetic data generation?
So yeah, we're looking of what kind of new project we can start, and Microsoft had released their 5 models, which were basically trained just on synthetic data. So I think that was the first time that synthetic data was used, not for fine tuning, but for pre-training. Because it's very common to use it for SFT to generate instructions. But what they did is that they generated textbooks and then they trained models on that, and they managed to get like really insane performances on the benchmarks. But they didn't release like the data sets or detailed information on how they built them. So people were skeptical about the performance of these models. Some were suggesting that maybe there's a lot of data contamination and that they trained on the benchmarks. That's why they were good. So me and a colleague decided, from who was also in Big Code, we decided to try to reproduce what they did. Because of Hugging Face, that's always kind of the motivation for all the projects. We try to reproduce something that's close to us. So we started building this data set called Cosmopedia, which is a collection of textbooks and stories and blog posts, and it was generated by Mixtral. So we basically prompt the model to generate a textbook about a certain topic, and then we train the model on this data set. So in the version 1, it was still not as good as 1.5 from Microsoft, but in version 2, we also augmented this with another data set, which is called FineWeb EDU. It's another approach. Instead of just generating synthetic textbooks, you generate annotations, and then you train a classifier to tell you if like a web page is educational or not. And then we only kept the web pages that were educational, and we actually managed to beat 1.5. And these are the models that we released recently. They're called Small.
So what do you mean by synthetic data generation? Your data set is 100% synthetic, meaning you simply prompt, I mean, simply, I guess it's quite difficult to do, but you prompt Mixtral 7B, that's the model you used, right? And so you prompt this model to generate stories, educational content, and things like that. And then you collect all of this, and that's the data that you use to train your model. Is that correct?
Yes, exactly. Yeah, we were using the mixture of experts, 7.8XP. And it's 100% synthetic, talking about Cosmopedia. We prompt the model. So first we need to decide like what type of data we want to generate. I think we have textbooks and stories and blog posts. And once you have a type, then you ask the model to generate textbook about a certain topic. For example, generate a textbook about linear algebra, and or you have to make the topic detailed about, for example, matrices, and then the model generates a textbook. And we did the same for a lot of topics, and then we end up with a collection of data sets. I think we spent a lot of time on the prompts because they basically like shape the quality of the generation and the textbook that you have. And one thing that's like very tricky is to have diversity, because even if we wanted to do topics, I think we could come up with at least 100,000 topics before we start to become repetitive. But the dataset has 30 million samples. So how do you go from like your few thousand topics to like millions of prompts? And the way we do that is that when we ask the model to generate a textbook about a certain topic, we try to find a web page that is related to that topic. And then we show that web page to the model and we ask it to make it somehow related to that page. This way, we force the model to use like certain information from that page. So your textbook is still new and synthetic, but you make sure that it is diverse because whenever you add a new web page, the model's generation is going to be different, even if the topic is the same. So this way we managed to like generate 30 million textbooks. The same for stories. We just changed the prompt. We ask the model to generate a story, sometimes for children, and we give some detailed criteria. For example, try to use a conversational tone, try to make the story simple or make it complex or have a complex in event. So the prompts are very diverse, and then we prompt the model and then we generate it. It's very expensive though because you basically need to use this model, which has like a lot of parameters. So we used our cluster. I think it took 10,000 H100 hours.
Okay. Wow. Yeah. So yeah, quite a lot. And so the data is fully synthetic, but it's generated with real data because you mentioned you were using web pages and things like that within the prompt to generate this synthetic data. Correct?
Yeah, so the web pages are more for inspiration. We don't post all of the web page, just maybe one paragraph. And if you look at the web page and what the model generates, it doesn't copy things from the web page. It's more use this for inspiration and for diversity. So yeah, that's the way we generate these textbooks. And like the whole motivation behind this kind of textbooks idea is what you mentioned, that like at school we usually learn this way. Like the first thing we learn is like textbooks, things that are very simple. And for a long time we've been training models just on the web, whatever is out there. And if you take a look at what's on the web, some things are really low quality. Even if you do your best to filter it, you're still going to have a lot of low quality samples and a lot of advertisements. So when you try to just generate textbooks and things that are clean, it's like you're trying to teach a child. You give them pages that are information dense, that are well written. And this is why this can work like better than generic data, at least for small models, which have like a small capacity.
And how do you generate? I mean, you still need to generate, I don't know how many million prompts, right, to generate all this data. So how do you automate this prompting process?
We basically have a prompt template for each data type. For example, for textbook, it's the same template. And then you just have to fill the topic and fill like a web page extract. So, I mean, we just have a Python script to go from like one template to millions of prompts. And then after that, we have a library, which is called LLM Swarm. It basically takes the prompts and then it uses an inference library, either TGI or VLLM, to query, to deploy a model. And then you send queries to that model that is deployed on your cluster, on your GPUs, to generate answers for these prompts. So you start from 30 million prompts, you did 30 million generations.
Okay, but templates, how many do you have?
There were maybe 7 or 10 templates.
Okay, so from 8 templates, you generate millions of prompts. That's quite cool. So for the topics, you mentioned earlier that the mix can be important. How do you decide on the mix of, I don't know, textbooks vs web pages or mathematics books vs history books? How did you decide on this?
We started from like a list of topics that we curated. I think there were 34,000. And each topic has like a subtopic. For example, you can have math, algebra, linear algebra. And then we used like also Mixtral to generate subtopics. So we could control like the distribution of topics, but it was more also like natural distribution, what you would find like in the web. Because at the end, you want the model to be like a good LLM. It should know like almost everything. So we started from books classification. It's called BSAC. Is publicly available and they give you like some topics, and then we didn't like really do any experiments to see how much data from each domain you should have. It's more like a natural distribution. We just made sure to like downsample. For example, there was like this juvenile fiction category which had a lot of topics, just like about stories. We didn't want the model to be just a storytelling chatbot, so we kind of downsampled that class. But for the rest, we kind of kept it. And then for the format, so we had like textbooks and we had stories. Those we did some experiments to see which ones help you the most on the benchmarks. And we found that textbooks are the ones that help the most. And I think it makes sense because these are the ones that have like more educational value than just generic stories and blog posts. So most of the data is textbooks, but then we had some stories because we found that they help some on some benchmarks for common sense reasoning. One other thing that was also very interesting is actually the category, like the audience that you generate your textbook for. Because when we prompt the model in our templates, we have a textbook for middle school students. So in this template, we ask the model to not generate complex and advanced things. For example, for math, I shouldn't find like a Riemann integral in there for like a middle school student. But we have another textbook for college students. This in that template, we ask the model to go like into deep details. And when we did the experiment, we found that it's better to generate more middle school content than to generate college content. So most of the data was actually middle school textbooks, but we also generated some college textbooks because we also wanted the model to be able to handle advanced information.
So in the template, you specify the topic, but also like the type of content that you want to generate, and also the difficulty level, like college or I don't know,
Yeah,
children or researcher, right?
yeah. It's usually three audiences, like college, middle school, and then elementary or
And what was the goal of this LLM? Was it to build a general LLM? Like once you've got this data, so you train a model on what was the goal of this model, how do you then evaluate it and compare it with which model did you compare it with?
yeah. So we're trying to reproduce 1.5, which was a 1 billion model.
Okay.
And we were evaluating on like common benchmarks that we use in NLP, like MMLU, ARC, and HelloSwag. So we also trained the 1 billion model. So with Cosmopedia V1, we were still short of the performance of that model. But in the V2, we generated synthetic textbooks and we also added like web data that was filtered based on educational value. Because we saw that they were also doing it for Llama 3 and they did that for like the next versions of Phi, like Phi 2 and Phi 3. And this with this approach, we were able to match or surpass their performance.
Okay. So you were able to beat the Microsoft model.
Yeah. And we found that like just generating synthetic data alone, I mean, it helps, but it's not enough. And it's not a very scalable approach. I mean, Cosmopedia, if you look at the textbooks, they look high quality, but I think 30 billion was kind of the max that we were able to generate. Because even like when you add like web pages that are related to the topics, you can't add any web page. It still needs to be a web page that is related to the topic.
Mm-hmm.
So you're still limited by then, and it's also very expensive. You could never generate a trillion synthetic tokens. So that's when we were like, maybe we should take a step back and see what other approaches we can do to actually boost the model performance. And especially since we saw that like in the new Phi models, they also using like filtering the web using LLMs. So maybe just to explain what that actually means. So in Cosmopedia, we were generating synthetic textbooks. In this new dataset, which is called FineWeb EDU, you basically take the web pages and then you ask the LLM to give them a score from 1 to 5 based on their educational value. So if, for example, it's an ad or if it's like celebrity gossip, it will probably get a score of 0 or 1. But if it's like a tutorial that's well written, it will get like a score of 4 or 5. So we have this scale and the model needs to assign a score. And we use this, so we get synthetic annotations that are basically pairs of like text and a score. And then we trained a classifier on that and we annotated all of FineWeb. And then FineWeb is like an English dataset that we released recently. And then we had a new dataset, which is like an educational version of FineWeb. And that one is so much better like than the base dataset that we started from. It gives you a huge boost to an MMLU and ARC. And so when we combine these datasets with Cosmopedia, we were actually better able to get like a very good 1B model.
So the key is to get a combination of synthetic and high quality non-synthetic data.
Yeah, exactly.
Where do you see like the future then? Do you think that future LLMs will, because synthetic data generation techniques will probably improve, do you think that the future models will be trained on synthetic data only, or do you think the key is actually to have a mix of both?
Yeah, I think these techniques, like using synthetic data to build classifiers to filter the web, are much more scalable than just trying to generate synthetic data. And for example, we tried that also for code, and it works very well. Like if you ask it to annotate Python code to only keep the educational ones, you get a very nice data set. And a lot of people also try to replicate what we did, and they managed to. So I think this approach of using LLMs as like filtering techniques for data sets are probably going to be more prevalent in the future. And using synthetic data as like pre-training samples can still be useful. But I think it maybe makes more sense to try to generate them for some specific domains. For example, have synthetic data for math or for reasoning, than to try to target like everything and have one generic pre-training data set.
Okay, yeah, very interesting point. I agree. You can train your model with real data, but filter by LLMs, see where your model isn't performing well. It could be math, it could be something, and then generate synthetic data on this topic to try to improve your model. Because if you start with synthetic data directly, it's very expensive and you might be doing it for nothing.
Yeah, and for example, this new data set that we generated, I mean, it matched the synthetic data, so why waste all that compute? If you can get, and it's more scalable. We get like 1 trillion tokens compared to just 30 billion synthetic tokens. So yeah, I mean, what you suggested is what a lot of people are doing now. For example, for Quen, DeepSeek, and Llama, they train.
Okay, cool. Yeah, I think this approach makes sense. Very interesting. And yeah, I wouldn't believe in synthetic data. I always thought it's, I don't know, it wouldn't be as high quality. But I think, yeah, when you lack lots of resources, then generating synthetic data on niche topic could be useful. Where I see an issue is, let's say you want to generate synthetic data on microbiology or whatever, which is a niche topic. Then if you use Mixtral 8x7b, for example, this model wouldn't know much about microbiology and so wouldn't be able to generate new content, if you see what I mean. So how do you cope with that?
Yeah, I think you can definitely have hallucination in like domains where the base model isn't good. But for example, now we really have very good models. For example, now Llama 3.1 is like, it has also permissive license. You can use the generations to train models. And you would be surprised at like the quality of the textbooks. They actually look better than the average web content. It's just a question of trying to limit the hallucinations. And I think, for example, you can try to generate data where you know the models are good. And I think today's LLMs are good like on most domains. For example, for some topics that are maybe niche, you could try to have techniques to verify what the model is generating. For example, for code, when people use it to generate synthetic data, you can actually execute the code and see if it runs. Um, there are some things that it can do like to verify the generations, but in general I think it's a promising approach. You can also try to have the model generate many samples, and then you use like maybe a reward model
Mhm.
or try to classify the generations and only keep the best one. So there are some techniques to try to improve the quality of synthetic generation, but I think it's like very promising. Really, what these models generate now, it's really good. It's much cheaper than human annotations. And as we have like more open models that are getting stronger, there's no reason we won't get better data.
So synthetic data generation will definitely become a bigger and bigger field in AI, you think?
For sure.
So a few career questions before we finish this episode. I think we dive deep into code generation and synthetic data generation. Wasn't actually, didn't know much about synthetic data generation, so very interesting topic. Something that yeah, I knew a company which was generating fake images. Um, I don't remember for what. I think it was for medical purposes. Don't even remember the name of the company, but yeah, on text generation, didn't know it was becoming so popular. But yeah, I think the usage makes a lot of sense, and it's great because the better the models become, the better they will be able to generate synthetic data, and the better the synthetic data, the better the model will become. So it will just boost AI progress. So yeah, very cool. So maybe to zoom in a bit in on your career, yeah. Well, this show is called AI Stories, so very keen to get a story from you. It can be anything, a mistake you've made, something funny, a project you've worked on. I don't know, whatever, but yeah, one story about you.
Maybe a funny story, although at the time it was not so funny. So when we were training StarCoder1, which was almost 2 years ago, so we were using Megatron library, and we would like save the intermediate checkpoints of the model on the cluster, and then we would evaluate. I think it was every 50 billion tokens or 100 billion. And yeah, at the time, like you would need to run like a script to automatically upload these checkpoints, like to back them up either on the Hugging Face Hub or S3. So now we have a much better checkpoint, like our own library, which does that automatically. But at the time, you had to do that manually. And I remember like it was like the release week of StarCoder, and I think it was supposed to happen like Wednesday or Thursday, and the model was still training on Monday. And I was traveling that day, so I gave like a local path of like the checkpoint to a colleague. I was like, okay, you're gonna find the model here, and you can do the evaluations. So I took my flights, and then I think I was in Italy. I arrived, and I opened my laptop, and I found the message. Oh, I think the path doesn't exist. It was deleted. And so it was panic mode everywhere because we had everything, but we didn't have the final checkpoints. So when I checked, apparently there was like this command at the end of the script, which basically means when the training ends, you should delete the path like to save space. So luckily we found that like we backed some checkpoints that were not like very far off. So we only had to train again for I think half a day. But it was very funny. Since then, like we proofread like all the scripts and we like automatically upload backups.
Had a small heart attack when you saw.
Like, it was like very good weather. Opening my laptop, oh, it's not there.
So just want to finish the episode with one advice. If you had one advice for someone to progress in their career, what would it be? Just one advice.
I think one advice is to try to be proactive, especially like in the AI and LLMs field. Like there are so many things that are getting released, so many new things, and it's very easy to get overwhelmed. It can be hard to try to identify which things are like important to focus on. So I think that's kind of like an important skill to try to develop and to find like the things that are most interesting, like maybe to replicate or to focus on, and then try to suggest that because it's very important to be able to adapt because it's a very competitive field, like whether it's training LLMs or building the best data set. So one day, like you can have the best model and then there's another one that comes out. So you have to find something like to distinguish like what you work on. So I think that's maybe an important skill to have like in the AI world.
Well, Loubna, thanks a lot. It was great to have you on the show and learn from you and your career. Have a great afternoon, a great weekend, and hope to catch up very soon.